So as usual, we have two speakers invited, Alex and Rifan. So Alex is our guest speaker, and he's a technical evangelist at AWS. And he's passionate about web development, data analysis, serverless, and everything about cloud. Let me hand it over to you, Alex.
Thank you everyone for joining, and thank you for inviting, really. So let's try to keep it interactive. It's online, it's not the same as meeting in person, but we have a chat room, you can ask questions. I have it here in my side monitor, so feel free to ask me anything during the presentation. Okay, we'll have a Q&A at the end. So before joining AWS, I was a web developer, and I've been a customer of AWS for about 5 years. So I know how it feels to be on the other side. That's why really just feel free to ask me anything, especially if you are building a startup, if you are a web developer yourself, or if you are into also a data science, machine learning kind of things. I also have that kind of background. So tonight we're going to mostly talk about web development in a serverless context, but feel free to ask me anything else, really. If you are shy and maybe you have a question tomorrow, feel free to connect as well. I'm on LinkedIn, I'm on Twitter. You'll find me on more or less every social media with Alex Casalboni. And so what's the agenda for tonight? What is serverless computing, how we think about it at Amazon Web Services, and what are really the fundamentals. And then we dive into some patterns, reusable patterns that make sense for web development. But web development is not just building an API and deploying it and writing some code. Sometimes you need to collect data, or sometimes you need to analyze and build reports and integrate artificial intelligence service. There's a lot of things you can do when it comes to web development. So tonight we're going to look at architectures to see what's possible, to see how all these 170 plus AWS services can talk to each other to help you build faster and whatever you're trying to build. So in a very few words, that's how Werner Vogels, our CTO of Amazon.com, talks about serverless. We think that the future looks like 90% plus of what you do as a developer is focusing on business logic. While what often happens at many organizations, maybe even in your organization, is that there are a lot more things that you need to take care about. A lot of heavy lifting when it comes to managing infrastructure, taking care of servers, patching the operating system, and all those heavy lifting kind of tasks that kind of still take time away from your productivity, from adding value. So serverless allows you to do that, to focus more on adding value. But it's not all, true or false. It's not like you either are serverless. There are things that are, of course, not serverless. Things like everything that runs on Amazon EC2, for example. Well, that's kind of the other opposite of serverless. There is also bare metal if you don't like the hypervisor and you want to bring your own hypervisor. But then there is a mid kind of category where you find a lot of managed services, but those are not fully serverless, meaning that even though they do a lot of things for you, they have automated backup solutions, they do high availability across availability zones, they do a lot of automation kind of things. You're still kind of aware about servers, about how many machines, how many instances, how many shards your EMR cluster or RDS cluster or a SageMaker deployment. You still have to do capacity planning. You still have to understand what scale you're going to have in the future or in 6 months. And it's great. Some of these services actually can operate in both modes. Services like DynamoDB, they provide a completely different pricing model that is, for example, pay-as-you-go or on-demand kind of capacity. That's very serverless because you don't pay for anything if nothing is happening in the system. But you also have the provision capacity kind of mode where you know exactly how much capacity you're going to need, and you are happy with provisioning it and auto scaling it over time. So some of the services can operate differently based on how you configure them, actually. And then you have the actual serverless category, where you find not only AWS Lambda, which was the initial kind of trigger around serverless computing. Lambda is just the function as a service component of it. It's orange in the logo, so it's the compute service related to serverless. But then there is a lot more. Then you have identity and access management. You have user and authentication management. You have orchestration. You have distributed tracing and object storage and RESTful interfaces. There is a lot more in the serverless platform than function as a service. And tonight we're going to have a look at all these services, how they play together, how you can basically, I like to think of the new cloud as a set of building blocks, a set of Lego bricks that you can put together to build your architecture, just by plugging in a lot of services together. That's part of the serverless way of thinking. You don't reinvent the wheel every time you need something. Some people call it service full, meaning that you end up using a lot of services, and Lambda is just the glue that connects those services. So in other words, some of the advantages of serverless are, well, you can kind of forget about provisioning, capacity planning, management, patching of operating system and security and all those things at the operating system or at the runtime level. You can focus on the high level business logic. That means your Lambda functions and everything that those functions connect in the system. It also means auto scaling, complete automatic scaling horizontally. You don't have to do capacity planning because Lambda does all that horizontal scaling for you in a matter of hundreds of milliseconds. So it doesn't take 5 minutes to spin up a Lambda function. It doesn't take 30 seconds, like maybe for a container, to spin up a Lambda function. It takes a few milliseconds. So that's really what triggered this revolution. And also, we used to say you don't pay for idle, but what is true is that you pay for value, because you only pay for Lambda when something is happening. Everything is event driven. And if there is no event, if there is no API call, no new object on a tree, if there is no new record or item on your databases, you don't pay for Lambda, basically. And that's also a pretty interesting aspect, especially if you're building a startup or if you're building kind of like a new idea or an infrequent kind of workload that you don't have thousands of requests per second. And another advantage that many people, many developers, many customers sometimes forget is that with Lambda, you also get the additional benefits of having a full infrastructure implemented with the best practical availability zones, so you don't have to take care of that if you deploy with EC2 or if you deploy with even with Fargate or ECS or Kubernetes availability of your infrastructure. With Lambda, all of that is taken care of. It's very transparent for you. And when you look at the prices, take into consideration all these efforts at the operational level that you have to take care of. But who's been adopting Lambda? Why are we talking about serverless? It's been there for about 5 years. And I can tell you that about 9 of the largest AWS customers, AWS accounts out there are using Lambda less than 5 or 6 years later. So I think 2020 is the first year where you can say that you have 5-year experience with Lambda because it's been already 5 years. I do not have 5-year experience with Lambda. I started in 2016, early 2017, when API Gateway came up. Anyway, it's been adopted very, very quickly by enterprises, startup, small and medium businesses. You probably have heard of most of these companies and organizations. I like to always always make the example of iRobot, those little Roomba robots that go around your house and clean it up. I really like that example because it shows you how a bunch of 2 or 3 people can handle millions the number of the number of requests per second they typically have during a regular day. Imagine after Prime Day or Black Friday, you know, a lot of people buy a Roomba and they go back home and they want to try it the next morning, and they have these crazy spikes. If they had to over provision to be able to manage those spikes, you know, they would spend hundreds of times more in the cloud or even on-prem. So with serverless, they don't really have to worry about those spikes because Lambda will scale. And it's not just Lambda, it's not just the AWS services, it's also about all the growing ecosystem around it, all the integrations, all the monitoring, all the developer experience, the deployment frameworks. You know, there is a lot going on in this space. If you haven't been looking in the last few years, have a look at it. Things like the serverless framework, services, and SaaS applications like IOPipe or Stackery or Epsagon or Sumo Logic. You will find a lot of very good stuff in this space. So what happens? How do these Lambda functions work under the hood? So basically what you want to happen is that we just run your code. You provide a little Lambda function. It could be 10 lines of JavaScript, Python, Go, Java, .NET, Ruby, whatever language you want, actually. There are some built-in runtimes. If your favorite language is not supported, you can probably find a custom runtime that would allow you to use it anyway. And but before we can run your code, we actually have to do a few things. We have to download your code, start a new, it's not really a container, it's more like a micro virtual machine powered by an open source bootstrap, their runtime, depending on, or a built-in runtime that we own. This initial phase is called a cold start. Cold because it doesn't happen all the time. It only happens every now and then. And it does add a few milliseconds, sometimes hundreds of milliseconds to the, you know, to the execution of your code. But this happens only after a while that you haven't invoked your functions, or when you're scaling horizontally very quickly, so that we have to spin up new runtimes. Also remember the idea of power. So your functions, you cannot independently tune memory and CPU and networking, IO, and those kind of things. You only have one handler that I like to call power, because if you just think of it as memory, it's called memory, RAM. But if you consider it just memory, you will end up not using Lambda properly. You have to think of it as power, because if you get your functions more memory, they will actually get more CPU power, more networking throughput, more IO, more everything, right? So think of it as power, and especially if your code, if your functions are CPU bound, it could actually be cheaper to run your functions with more memory. That's a big to a computing platform. It's going to be more expensive. There is no way you can work around it. With Lambda, it's slightly different because the pricing, the pricing model is pay as you go on a 100 millisecond interval. It means that if you can run faster with more power, you might be spending less or maybe the same. But still, if you can be twice as fast or 3 times as fast and pay the same, I think that's a pretty cool achievement. And I was pretty frustrated with this issue back in 2017. I was still an AWS customer, so I built a data-driven tool that would allow you to optimize your functions for the optimal power configuration. So I called it Lambda Power Tuning. It's an open source project. You can check it out on GitHub. You can contribute, you can ask questions. Feel free to reach out if you are curious about it. It's not the topic for tonight, but it does give you a lot of insights. You can plot charts, you can understand how your function operates at different power configurations. And as you can see, sometimes the execution time improves a lot, while the cost is pretty stable, and sometimes it's even cheaper to run. So we can topic. For now, let's go on into the actual topic for tonight. We want to talk about web applications, microservices, APIs, anything related to web development, right? So this is the typical modern web application architecture in a very simplified way, of course, but these are the basic components. So usually you have a web browser, a client, and usually you want to split your front-end logic from your back-end logic. So your front-end could as well be a static website. Maybe you generate that website with some front-end framework like React or Angular or Vue.js, or even your own simple static website, whatever. And why is that a good option? Well, because then you can CDN mechanism. So it's fast, it's globally distributed. There is no bottleneck, there is no server capacity, there is no capacity planning that you need to take care of. So serving the front end this way is just the best way to do it. And also it allows you to decouple the two projects. You could have one team working on the front end and another team working on the back end. And all they need to know about each other is maybe the API documentation of the back end. The back end doesn't really need to know about the front end at all, but the front end does need to know about the back end. So usually you want to deploy your assets, your images, your JavaScript, your HTML, or your whatever huge JavaScript bundle built with React on S3. And sometimes if it's not a completely public website, but if these APIs require some sort of authentication, authorization, you can use a service called Amazon Cognito. So I don't know how many times you have implemented user, I forgot my password, multi-factor authentication, all these functionalities that basically any application needs to have. Every application needs some kind of user management. And I've implemented this in my career maybe 10 times, maybe 15 times. And every time I've done it differently, with a different framework, with a different language, with different conventions, with a different maybe security concerns about encryption and all those best practices that you want to have when handling users and passwords and private, personally identifiable sensitive information. So Cognito will do a lot of that for you with Cognito user pools, but Cognito also does a great job at providing your client-side code with temporary credentials to be able to invoke your backend services. That could be invoking an API, but that could also be invoking DynamoDB directly or any other cloud service directly from the browser with temporary credentials that are not hard-coded in the client-side code. Anyway, so what usually happens is that you have the backend, and in the typical case of serverless development, you have some RESTful API. It could be a GraphQL API with AppSync, but usually, still in 2020, most organizations are still using RESTful as a communication interface. So you want to have API gateway in front of your Lambda function. The API gateway does a lot of things. It does throttling, it does routing, it does request response, manipulation. You have tons and tons of features. You have usage plans, API keys. There are a lot of features in there. But the simplest way to use it is to use it as a RESTful interface just in front of your Lambda functions, okay? Here you will have your business logic implemented in any programming language. And usually you also want to get some data, some dynamic information based on the requests. So you store that information in a database. This is the typical 3-tier architecture. We have just split backend from front end, and we have just split the routing or maybe you're used to Nginx or projects like that. In the API gateway layer, we have split the backend logic from the database into two different services. Lambda will do the business logic, Dynamo or RDS or Aurora or Neptune or any database you can think of will do the data layer. There are a few variations of this. So as you noticed, here we have put CloudFront in only for the front end. There are cases where you may want to have CloudFront also in front of your backend. And it could actually be the same CloudFront distribution. Now, this is useful for a few reasons. The main two, in my opinion, are, first of all, if you do this, your website and your backend will be on the same domain, will be on the same origin. And this simplifies a lot the cross-origin configuration. It is slightly different, slightly simpler. I wouldn't say this would justify putting API gateway behind a CloudFront distribution or CDN, but still, it might help you get started. Another good reason is that if you do this, you can actually use a lot of other CloudFront functionalities like Lambda attach, or like the web application firewall integration. You can set up firewall rules both for your front end and your back end. Lambda attach, I think, is particularly interesting because it allows you to change their request and their response before or after it gets, if you have CloudFront here and some of these GET API responses might be cached, you also have a free caching layer in there. When it comes to API gateway, I've anticipated it's a very sophisticated product. There is a new version of it, and we called it HTTP APIs, and that's slightly simpler, cheaper, faster, meant for very simple use cases. But if you look at the traditional API gateway service, you have mainly three different endpoint types based on the use case. The first one is edge clients. Your browsers, your potential customers in this case, are all over the world. You want to optimize latency from customers that are everywhere around the world. The second type is regional. Regional because there is no CDN in this case. In the edge optimized case, all the requests go through the Amazon global network using the edge network, which is basically the same network used by CloudFront and all the other edge services. In the regional endpoint type, you do not have any CDN involved. You go straight to the AWS region where you have deployed your API. So if I deploy my API to Singapore or to Dublin or to Oregon, and I'm somewhere in the world, if you call that regional API, you will have to go through the internet all the way to Singapore, Dublin, or Oregon. Okay, so the network is not as optimized because regional endpoints are ideal, and they are the best option if the consumer of that API is already in the region. Okay, imagine that I have some other internal services that I have deployed and developed that need some internal API, and so I don't have to use an edge optimized endpoint for those kind of use cases. I can use a regional endpoint, and because it's regional, the API request will not have to go out of the AWS data center. Maybe it will change availability zone eventually, but it will stay within the Amazon network. It will not go out on the internet. And then there is a third API type. It's called private. This is slightly different because it's not meant for public use. It's meant to be accessible only from within an Amazon VPC. So this is really for only internal consumers, not the general public. And this might make sense for use cases where maybe you have on-premises setups. I'll show you a chart in a second. So this is the typical edge optimized use case where your customers are somewhere on the internet. they will call an edge optimized endpoint. They will go through the CloudFront network basically, and then they will finally reach the region where you have deployed the API gateway. This is to optimize the latency at the global level. The regional endpoint, in this case, I wanted to tell you about a specific use case that is particularly useful for resiliency. Another good reason why you want to use regional endpoints is for building multi-region, exactly the same stack into two different regions. I think in this case, I have something like, I think my presentation just stopped. Sorry, guys. I don't know what happened to PowerPoint. Can you still hear me, guys?
We can hear you, Alex.
Yeah, sorry. I think my PowerPoint is just frozen. So I'll keep talking until it unfreezes itself. So if you can see my screen in the regional multi-region architecture, what I can do is I can deploy my application exactly the same stack to two regions, and then I can use Route 53, the DNS service of AWS, to do latency-based routing, for example. So if a user comes, I can route that user to the closest region. It could be Oregon, Virginia, again, Singapore, Dublin, whatever, Sydney. And this is good because first of all, you can optimize the latency and at the same time be more resilient. Imagine that something for some reason goes wrong in one of these two regions. Route 53 will be able to detect that one of these two regions is not available anymore, and they will be able to route all the requests to the other region, which is still up and running, right? So this could be an active setup where you have both regions active and serving requests from users based on the lowest latency. But it could also be an active passive setup where you have the traffic goes to, and then you have a secondary region which is usually inactive. There are no requests going to that region, and it's just there waiting just in case something goes wrong in the other one. And this is great with serverless because this secondary passive region is not costing you anything because all the services involved are serverless, are pay as you go. If there is no event, you're not going to pay anything. So I think this is a great solution for increased resiliency and availability with serverless architectures, also to keep the cost down. Usually if you want to increase resiliency, somehow you have to increase cost as well. So that's another interesting way to look at it. So let me see if my PowerPoint has recovered yet. I'm afraid not. So let me stop sharing for a second. Sorry, guys. I think Zoom is trying to mess with me. So let me try to figure out a solution here.
Alex, are you stop sharing and then resharing?
I think we lost Alex.
Yeah. So let's try to. Yeah, let me connect to him offline and then try to get him in again.
Hi guys, am I back?
Hi, Alex.
Hi, sorry about that.
Hi,
Let
it's
me
no problem.
try to go back to where I left. Can you see my screen?
Yes,
All
we can.
right.
Yeah, we can.
Okay.
However, I think
You
it's
see?
in presenter mode.
Yes, let me swap. Here we go. Okay, cool. So we left at the multi-region setup. I hope you heard me up to that point. And what I also wanted to focus on was the security implications of using this kind of very simple architecture. So usually we want to set up our we want to serve our static front end with HTTPS, and that's super easy with CloudFront. You get free certificates. There is also a service called Amazon Certificate Manager, ACM, that will do a lot of the work when it comes to renewing those certificates and mapping those certificates to your CloudFront distribution. You can do custom domains. You can do a lot of things there just to get encryption at the basic level. But also CloudFront will help you when it comes to maybe protecting some specific content. Maybe you want some URLs to be signed, so only someone who has paid for that content, or only someone who is a one-to-one invitation between customers, they will be able to access that kind of content. And the same you can do with S3. You really have full access of who can access what in your S3 buckets. Of course, if this is a static website for a public website, usually you want every object to be accessible by everyone. But because you are using CloudFront, you can configure your own access policies there. I've mentioned how Cognito can help you with dealing with authentication and authorization and users management, and that's already by itself a huge security improvement. You have no idea how many companies and developers are still storing their users' passwords in clear and stuff like that. So you forget about all those problems. When it comes to API gateway, I think the most interesting function here are related to throttling and all the API rate limiting kind of management that you have. So if you want some, a group of customer, you call them, I don't know, freemium, and you allow them to only invoke this API, I don't know, 10 times per minute. Okay, that's there. And you can name them, I don't know, premium or paying customers. And you allow them to access your API, I don't know, 100 times per minute. So you can configure throttling and rate limiting on and these groups are called usage plans. When it comes to Lambda, cannot invoke any other AWS service. Okay, if you want Lambda to be able to read data from Dynamo or to put a new item or a new object on S3, or do permissions to your Lambda functions to do that. So you have full control about who can do that. You do that with function policies and execution policies. You have environment variables that can be encrypted. You can also store and fetch configuration parameters and secrets and password via third-party services or via AWS services like the System Manager Parameter Store or the AWS Secrets Manager. And these are very nice services to externalize the management of secrets and configuration parameters. You do not want those parameters to be hard-coded in your function. Sometimes you don't even want these parameters to be set up as environment variables, just because maybe you have 25 functions consuming those configuration parameters. And if you need to change that one value, you don't want to read it. Will go and fetch the value at runtime. Similar considerations hold for DynamoDB and other AWS database services. I think Dynamo is a great example because you have not only encryption in transit and encryption at rest of all your data, you also have very granular permissions about who can read the data. You could say this function can read only this table in DynamoDB, but only these columns in the database. So you can have very, very granular settings. When it comes to authorization, so usually, if it's a backend API, it could be that you have some endpoints that are static, not static, that are public. You could have some other endpoints that do require some sort of authentication, and you can do that with Cognito and federated identities. But sometimes you need something more, and you need to add some custom authorization logic, either to set more granular permissions on some specific endpoints, or maybe to integrate with third-party identity providers. So you can do all of that. Usually you have a client, again, your web or your mobile client. They will get a token from an identity provider. This could be Gmail or Facebook or OpenID, whatever is a SAML or a generic identity provider. And this client will use that token and will pass it to API Gateway in one of the headers. It could be a custom header, it could be the default authorization header. And API Gateway, before invoking your backend Lambda function and database and all of that, will pass that token to a custom authorizer. This is another Lambda function that will take the incoming request and the header, the authorization header, to verify it. It could be a JSON Web Token, and you can super easily validate that JSON Web Token with a private key, or you could invoke your identity provider and say, "Hey, is this token valid?" And once the authorizer is done, you can come back with a OK or KO, or even with a custom policy that grants this specific identity with specific permissions related to your API structure. It could be providing only get access to some resources, maybe get and post access to some other resources. So you can be also very granular here. And of course, this does not happen at every single API requests. The result of the Lambda authorizer is cached from API Gateway. So you're not hitting the identity provider, or you're not hitting the Lambda authorizer every single time. After that, what will happen is that either API Gateway comes back with a 400 error saying, "I'm sorry, you do not have permission to access this API," or it will go on and invoke Lambda, and Lambda will invoke the database, and the usual flow proceeds. Now, what if my requirements are slightly different? Maybe you just need a CMS. So do you need to do that serverless? Well, maybe you can just spin up an AWS light sale account. Okay, sometimes your company, your organization, or your marketing team will just need a CMS like a WordPress or a Drupal or something super simple to handle the front-end side of things. Now, you could do that with a new custom-built serverless application, but what will happen is that maybe this team will depend on you to update the content. And do you really want to build a new CMS from scratch? So my suggestion is use a CMS that works. Lightsail is a good way to get started. Of course, there are many other options also developed in the community. There are even like serverless WordPress kind of solutions that will give you WordPress for 10 minutes. You do the edits, you save, and then everything will be serialized into a static website. There are a lot of options in this space too. And sometimes you would just want to build a monolith. Okay, you don't need to. Maybe you have an existing application. You could try and migrate that to Lambda. There are many ways to do it depending on the language and the framework. But sometimes the easy option is just go and try to use something like Elastic Beanstalk. It's been out there for a while. It's very stable, mature service. There is a lot of functionalities related to horizontal scalability. So don't forget there are other options out there. what I see nowadays is that companies either choose, serverless with two approaches, either a backend focused kind of approach. So you focus everything on your API layer, you build your API gateway and Lambda integrations, you integrate Cognito, you integrate S3. Maybe at some point you can add in more use cases. So maybe you need Fargate for some long running processes, or you need to integrate API gateway with some other AWS service. It could be Kinesis, or it could be SNS, or it could be even DynamoDB directly. And this is great because you build the API once and then you can use it from your other services, from your web clients, from your mobile clients. But there is a second way to think of this, and it's to give your team a very strong front-end focus. This is great also for, sorry guys, apologies. This is great for startups that need to hire maybe the first few people in the company, like 1, 2, or 3 developers, and they want to experience. So you can focus on hiring a couple of very good front-end engineers, and they will just be able to take care of everything without having a super, super deep experience with cloud resources management. So with tools like AWS Amplify, with tools like AWS AppSync, you can build a super quick full stack application, just focusing on the front end side of things. And Amplify will connect AppSync to Dynamo, Aurora, Elasticsearch to your Lambda functions, to Cognito authentication, to a CDN if you want to serve static assets with CloudFront. So you really don't have to have a 10-year experience in CloudFormation and Terraform and all the DevOps best practices. You can just focus on the front end and be happy with that. Another interesting service that some people sometimes forget is Amplify Console, because Amplify that I've mentioned here is a CLI tool and a framework that allows you to build front-end applications with React and Vue and Angular and those kind of frameworks. But it's also a deployment service called Amplify Console that allows you to deploy static or single-page web applications. And these applications don't really have to be built with Amplify. It's called Amplify because it's part of this suite of services, but you can choose what you actually need. So this is a good alternative to using, for example, S3 and CloudFront. So Amplify Console will replace S3 and CloudFront for your static website distribution. And it comes with a lot of very high-level features like multi-device preview of your website, domain management, email notification, automatic continuous integration connected to your Git repository, access control, mapping of your Git branches to a subdomain of your website, like myfeaturebranch.mycompany.com. You can map those subdomains to specific branches in your Git environment. And you can even automate that. So for every new branch, you can create a new subdomain in your Amplify project. So this is super, super powerful in my opinion. And then there are other kind of side projects when it comes to web development, things like data ingestion. How do you collect data that you need to analyze, maybe to build a report, maybe to have some real-time analytics of what's going on in your website. So for this kind of things, I like to use one service that is called Kinesis Data Firehose. Okay, this service is part of the Kinesis family, and I'm trying to focus today on Data Firehose because it's the one that is 100% serverless, because you don't need to do any capacity planning, and it's great to just basically just throw data at it with your record producers. And this could be your static website. You don't have to put a server here. This could be directly your front end, or it could be your backend, depending. And you just put records into Kinesis Firehose, and then you configure it to deliver those records to an S3 bucket or a Redshift table or an Elasticsearch domain. And the Firehose will take care of the rest. Will encrypt the data, compress the data, and take care of even transforming it. And optionally, you can bind
a Lambda function to your Firehose delivery stream to do data manipulation in real time, right? So a new record comes, you can augment it, enrich it, filter it, or just change the shape of it before you give it back to Firehose, and then it gets delivered to S3, for example. I really suggest S3 because S3 is great to ingest all these historical data. This could be events that are coming, clicks from your web client, whatever is happening. And you can very easily enable compression, parquet transformation. You can change the buffer size and the buffer interval of this Kinesis Firehose delivery stream. If you know that you're going to have a large throughput, it's good practice to keep a buffer size that is large enough so you can compress more, and it's going to be cheaper because you will do fewer API requests to S3, and you will also have larger objects on S3, and that will help you analyze it later on. But then how do you query all this data? Well, there are multiple ways. The way I recommend doing it is using Glue to automatically create the schema for those kind of data. You might have different schemas, different applications might be sending data through, and you might end up with multiple virtual tables on Glue. Once you have these virtual tables on Glue, you can very easily query those with Amazon Athena. So Athena is a managed version of the PrestoDB. It's basically an SQL interface on top of your object storage data. This data could be in CSV or JSON or Parquet formats, and you basically just query an SQL query, right? And I think the best flow here is that from S3 and Athena, you go straight to QuickSight, which is a nice service to visualize data from almost any data source. So data could be even directly S3 or RDS or Athena or Redshift, but I really like to use S3, Athena, and QuickSight to have a super simple flow to filter or aggregate data. And this is basically a kind of a simplified data lake architecture, okay? Athena looks like this. You have a query interface, you have a big button in here, and you run the query and you get the query results out. Of course, the same can be done via API as usual. This is a typical Athena query. It's using the Google Ngrams dataset. By the way, there is this open data registry from AWS. All the data is already stored and archived and optimized in on S3, usually in Parquet format. And you just have to define the Athena table, and in 1 second later, you can query the data. So the data is only stored once, and we pay for it. You just have to query that data with Athena. I think this is great. And how does Athena pricing work? Well, imagine this is a pretty large query operating on a few gigabytes of data, and yeah, about 170 gigabytes of data. And it runs in about 45 seconds. But if you try to run it in your laptop, it would probably be a few hours. So it runs pretty quickly in Athena because everything can be parallelized. And you pay about 85 cents of a dollar because the pricing of Athena is not based on like the typical database. It's not like you pay a fixed amount per hour or a fixed amount per month. It's pay as you go. It's based on how much data you are scanning. So I think it's pretty cool. It's pretty flexible, and it allows you to grow your analytics cost linearly with how much data you have. And as you can see here, we are grouping and we are applying a where condition. I think the total size of this data set is something like 2 or 3 terabytes. But we are only scanning a subset of the data set because of these where conditions. So if you apply the right conditions and the right filtering and the right grouping, you can optimize your the cost and the performance of your queries as well. And here there are a lot of best practices. You can create partitions. You can use columnar formats. And if you remember, Kinesis Data Firehose creates those columnar formats automatically if you just click a couple of checkboxes. So it's super powerful to use Athena and S3 and Firehose together. Couple bonus points, so I don't go too late and we have time for questions. You know, sometimes what you really need is some smart functionalities. Something like I need to convert this audio file from audio to text, or I need to find some images, some objects in an image, or things like that. So there are a lot of artificial intelligence services on AWS, and they are pretty simple to integrate with any website or mobile application, just because they are one API call away. I always like to say that if you can make an HTTP request, you can use an AI service nowadays. It's just super easy. So a typical example here is, imagine you have an e-commerce, and here you have your website, your web server, or your Lambda function. At some point, your browser will need to show some recommended items. You know, think of Netflix, it will be movies. If you have an e-commerce, it will be items that people can buy. So the browser will send events directly to Personalize. Amazon Personalize is a service that will take all these events and your historical data and generate a custom artificial intelligence API for you to generate new recommendations out of your catalog of items that can be, you know, bought, viewed, purchased, whatever. So at some point, the browser will request your server or your Lambda function, hey, give me new recommendations. You will just do one API call to Personalize that will come back with some list of recommendations. Here you can augment it, enrich it, filter it, do some additional processing if you want, and then you return it back to the browser. So this is super easy integration with artificial intelligence services like Amazon Personalize. Same thing you can do in a more event-driven fashion. If you need to transform an audio file into some actionable insights, for example, you might store that file on S3. You might introduce a new object. You trigger a Lambda function. And then you can invoke another service called Amazon Transcribe that will take the audio and come back with some text. And then you can take that text and go through Amazon Comprehend. They will analyze the text, extract the sentiment, extract the key phrases, and do some sort of natural language analysis on that text. And eventually you can store that data back to S3 and use Athena and QuickSight to visualize that data at scale. Maybe you have hundreds and hundreds of videos or audio files uploaded every day, and you may just automate this process to get a nice dashboards of, you know, sentiment and key phrases and so on. Same with images. Imagine you have customers uploading images. You can do the same event-driven kind of trick, and then in parallel you can use something like a step function, which is like a visual orchestrator of Lambda function, to invoke Amazon recognition, to do face detection, object moderation, maybe even OCR, optical character recognition on top of these images, store that data back to a DynamoDB table, to an Elasticsearch domain, to do all sort of things. One last example, imagine that all you need is a contact center. There is a new great service called, don't know about it yet. So Amazon Connect is a contact center as a service, and it's fully serverless. So nothing to install, no EC2 instances to spin up. So let's imagine that you have a customer calling you at, I don't know, 2 a.m. in the morning, and there is no agent able to respond that call. So maybe this customer can just talk to a chatbot or to some smart functionality in your system. So customer will say, hey, I need to reschedule an appointment, for example, and she's calling your call center. So you can integrate Amazon Connect with Amazon Lex, which is like the heart of Alexa. If you know Alexa, Lex is kind of the engine compatible with Alexa skills. So you can model the conversation, you can build intents, you can build kind of conversational interfaces. So Lex will take care of extracting the relevant information from that conversation, will pass the information to Lambda, and Lambda will be able to maybe do a quick check on the database, update the appointment date, and who is happy even if it's 2 a.m. in the morning, and you could manage that reschedule very quickly with a smart functionality. So again, I wanted to give you an overview of what architectures are possible, some of the patterns, some of the services, some of the integrations, and some of the benefits of thinking in a serverless way. I hope it was useful. My call to action for you is just go and build something cool. Take this as an opportunity to build a prototype, to experiment, to build a startup, or to do something fun and crazy with serverless. Thank you.
Hi. Can you guys hear me? Hello? Hello? Hi, guys. Hello? Hi.
Hi there. Feel free to ask me anything. I can hear you.
Okay. Hi, Alex. Thanks for the great presentation. Yeah, actually, I myself have two questions. Yeah, hope
Sure.
I'm clear because the connection seems to be very unstable at my end. So the first question is, Alex, like you showed, if we want to ingest data, we can use the Kinesis Firehose and like directly like put all the data in there, and it will manage to take that data to the corresponding locations like S3 and all that. And then we can use Athena to query it, right? So
Yeah.
is it possible to expose an endpoint, an API endpoint, so that our web application can also consume that data, like through those queries passed through the from the front end, without just using the Athena console? Is it possible to expose it as an API? So that's one of my questions. Yeah. Did you get my question, Alex? Hi. Hello.
We can hear you, Manoj, I think.
Okay. Hi, Alex.
We can't hear Alex.
Back. Sorry, guys. So yes, it is possible.
Yeah.
Just keep in mind that Athena is intended for an analytics kind of workload. It's not really a database that you would go and query with like hundreds of requests concurrently, right? So it's more considerable like a data warehouse or a data lake. So if your web application that needs to access those kind of analytics only has a few users, like you always know that there will be 3, 4, 5 concurrent users, that will work fine, like some admins or some co-founders of your company, your CTO or your CEO. That would be great, because I think there is a maximum, if I remember correctly, there is a maximum of 5 or 8 concurrent Athena queries that you can do, because it's more intended as a reporting analytics kind of service. So in that case, you want to run a very not expensive, like a very heavy query, maybe once or twice a day, which is slightly different than having 20 or 50 or 100 users requesting all this data concurrently, right? That's more of a database workload. So what I recommend is that you actually go and build a dashboard with QuickSight, and then you integrate QuickSight into your website. Does make sense? Yes. So QuickSight will take care of caching the Athena results in memory, so your charts and your visualizations are always warm, and you don't have to wait to see those charts.
Yeah. So thanks, Alex. And I have another question, so I'll ask in a row. So the next question is, Alex, sometimes back we had this Lambda called start issue, right? And then came this Lambda provision capacity as a solution. And so my question is, what are the cost implications for the Lambda provision capacity, and also how are we determine the ideal number of provision capacity for a Lambda function? What is the process, at least, the determining, okay, how many provision Lambda should we have, let's say, for this particular function? What are your thoughts on that, Alex? Because with Lambda, when you have just Lambda, it is not going to cost anything else if there's no any events. And if you have provision some capacity, then again, I think you might have to pay for that provision capacity. And how are we go about identifying the best practices around provision capacity, Alex?
Yeah, that's a good question. And yeah, it might be slightly different from what we used to do in the past, where, a lot of people adopted serverless because you didn't have to provision capacity, right? The reason why there is this new provision capacity, as you mentioned, is to get rid of cold starts, okay? And I think it actually works to help you with rid of cold starts in a use case where you can predict more or less when this kind of a cold starts will happen. Like a typical use case is, imagine that we have a predictable spike, I don't know, tonight at 9 p.m. because there is a match or some sport event, or you expect a lot of people to come in, and you will have thousands of concurrent invocations or hundreds of concurrent invocations to your APIs. And you don't want all those hundreds and hundreds of customers to experience all of them a cold start, right? So in those kind of scenarios, I think provision concurrency makes a lot of sense because it's predictable. You can make sure you have enough provision concurrency. So basically you have enough warm run times with Lambda at the time of the expected peak. And I think that's great. It's super easy. You don't have to mess up with CloudWatch events or manual pre-warming, which were the techniques that people used before. So it's much easier now. Also remember that there is a ramp up time. So if you need 1,000 warm runtimes, it might take a few minutes to get there. If I remember correctly, it's something like 500 per minute. So it's pretty quickly. But last year at reInvent, I met a customer who needed 30,000 concurrent runtime. So, that would take minutes, even hours to spin up. And after that, you have 30,000 warm runtimes, but it's not immediate, right? And from the cost perspective, it's true what you said, that, it is slightly against the initial idea of Lambda to have this provision concurrency that you pay for it, even if you're not using it, right? So it's kind of against the initial idea of not having to think about capacity in the first place. That's why I think it will really help you for spikes and peaks that you can predict, and that at least you're going to have 1,000 concurrent requests. So you can cover those. And if you have more, you will pay for the remaining, for the additional ones in the regular pricing. So my suggestion is try to predict how many you're going to need and provision that. If you have more, it's fine. You're still saving money and you're improving the experience. If you have less, well, you are over provisioning. The good news is that you can map provision concurrency to auto scaling as well. So you can say, okay, this is the initial value that I'm providing, but also please auto scale up and down based on the actual current demand, right?
Yeah, thanks, Alex.
Does that make sense?
Yeah, that makes sense, because in my project, we introduce provision capacity for several functions, and it starts the cost and everything goes up quite a bit. So then again, we were thinking kind of like really analyzing the situation, like you mentioned, what are the spikes and everything, then only did the provisioning capacity. And now things are okay, because what we have originally practicing was that scheduling function that will call the Lambda function in a certain interval and so on. Now we are using kind of a mix of those provision capacity and that model just to minimize the cost aspects as well.
Yeah, it's more of a user experience concern, right? If you want to get rid of cold starts, it's because you want to improve the experience of your API consumers. And I think most organizations are happy to pay a little bit more to fix a UX problem, right? So of course, it's not something you get for free. It's a trade-off as usual. You know, with Lambda, you can go faster if you give it more power. And this is the same idea. You can get rid of cold starts if you're willing to pay a little bit more, because it's worth for you. I think there was a study back a few years back that says every 100 millisecond of additional latency to your API in an e-commerce context will cost you X% of your annual revenue. Those kind of studies prove that if you can shave off 200 or 300 milliseconds on average from an API, you will see a business impact. So I think that's where this idea of provision concurrency makes sense.
Yeah, exactly. Thanks, Alex. Yeah, guys, if you have other questions, please feel free to ask.
No problem. Everybody's shy on Zoom.
You can unmute yourself,
Hi,
maybe
Alex.
like.
Yeah. Hi, Alex. I'm Indika. So, I have a question. This may not be directly connected to the serverless, but say, what is your take on over RDS, this Aurora and MySQL? When we are choosing between one of those, whether to use my engine as Aurora based on MySQL or directly MySQL, RDS MySQL. Yep. Any takes on that?
That's a tricky question. I think choosing the right database in 2020 can be tricky. There are a lot of those options. I think unless you have very particular technical concerns or technical requirements for your application, I think I would go where you're more comfortable with, where you have more experience yourself. I mean, unless it's a use case where okay, you need a graph database because you need to analyze relationships between hundreds or thousands of items in a network. Unless you have those very edge case scenarios and you want to use like a graph database or a ledger, like quantum ledger database or something super specific, I think if you have 10 years experience with MySQL, go with MySQL. I mean, you were asking though, should I run MySQL on Aurora, on EC2, running it myself, or on a regular RDS? So in that case, I think it's also up to your experience. If you have 10 years experience in managing databases at scale, taking care of horizontal scalability, maintenance and backups and those kind of things, feel free to do it. Myself as a developer, I would always suggest you use a managed service because you want to invest your time as a developer on creating feature, improving the service, or improving the application that you're building, not on the heavy lifting of configuring backup or patching the MySQL minor version every month. Those are kind of tasks that have been solved and you can automate them with a managed service. So I would not recommend you run MySQL on EC2 in 2020. Between Aurora and MySQL, on RDS, it kind of depends. Aurora has a slightly different pricing range because it comes with scaling out functionalities. And if you need a lot of read replicas, if you need a multi-master kind of multi-region, multi-master kind of database, Aurora is great. If you need a data API that doesn't require a MySQL driver, like if you want to use Lambda, it's pretty cool to use an API, like the data API with the SDK, without having to always use the MySQL driver. There are pros and cons. I think if you are planning to scale a lot and you want to scale especially reads with the 12 or 14 read replicas that Aurora can give you, I think that's a considerable advantage. But at the end of the day, it's up to you. I would say between RDS and Aurora, there are a few differences, but I would say you can even start with RDS, and if you realize you need more scale, you need more read replicas, you need more multi-region features, or you need a data-driven API like the data API of Aurora, you can migrate later. But yeah, it kind of depends on what you're building too. Does it make sense?
Yeah, Alex, I think it makes sense because I am in the process of setting up a production environment. So in that case, so for the div and staging environment, we had been using the Aurora database service.
Yeah, there's
so,
also
yeah,
Aurora
yeah.
Serverless that I haven't mentioned, and that's kind of a special use case if you have infrequent workloads or if you have crazy spikes that wouldn't really be easy to solve with auto scaling. So Aurora Serverless is an interesting option for serverless applications too.
All right, thanks, Alex.
My pleasure.
Okay, guys, do you have any other questions? If you have, like, unmute yourself, otherwise we can't hear you. Okay, looks like they don't have any more questions. So thanks, Alex, for spending your time with us. Thank you very much for your interesting presentation. It was really great presentation. Thank you very much again.
My pleasure. Thank you for inviting.